Good morning, everybody, and welcome to this new season of SageMaker Fridays. It's season 4 already. My name is Julian, and I'm a principal developer advocate focusing on AI and machine learning. Please meet my co-presenter.
Hi everyone, my name is Ségolène, and I'm a senior data scientist working with the AWS Machine Learning Solution Lab. My role is to help customers get their ML projects on the right track in order to create business value as fast as possible.
Thank you again for joining us. We will definitely need your expertise. If you're new to SageMaker Fridays, you will quickly find out this is a 100% demo, right? We just have a few intro slides to let you know about this new season, but then we're going to be running code and diving into problems. If you have questions, please ask all your questions. We have moderators who are ready to answer everything. So just don't be shy, ask anything that you'd like to know, and make sure you learn as much as possible. Okay? So here's the agenda for this new season. It's actually in 3 parts. So we have the first 4 episodes that focus on, I would say, the data science part of machine learning, where we prepare data, train models, explain models, etc. And then we'll have 4 more episodes on ops in general and automation, a strong focus on automation. And we'll probably revisit some of those early examples and add automation to them. And finally, we have 4 episodes where we look at AutoML, so trying to automatically build models. Okay. So quite a lot of episodes ahead of us, and hope you find them interesting all the way to October 22nd. So what are we going to talk about today?
So today we are going to work on a music recommendation problem.
Okay.
We will focus on the data science and machine learning angle. We are going to cover data preparation, deployment, deployment, prediction, and explainability.
Okay. Yeah. So let's look at the pipeline, and don't worry, we'll show you the URL again if you didn't catch it the first time around. So this is the end-to-end workflow we're covering, and it's really a good opportunity to learn about many of SageMaker's capabilities, right? So we'll start from a data set. We'll get to that in a second. And we will use SageMaker Data Wrangler to process it and basically run feature engineering. And then we're going to ingest the engineered features into SageMaker Feature Store. And next, we're going to use those features to create a data set, and we'll actually use Amazon Athena to query the feature store and retrieve data. So that's really a really cool technique. And then, of course, we're going to use that data set to train a model, and we're going to use XGBoost. And I have a question on that. And we're also going to use SageMaker Debugger during training to capture the model state, and particularly we're going to use that data for explainability and feature importance. Okay, so 2 really important things. And we'll stop there for this episode because there's so much more we want to talk about, but we'll talk about the rest, mostly automation, the model registry, model monitor, all those ops concerns in a September episode. Okay, so for now, data prep, feature store,
data science,
training, and explainability, and feature importance. Okay, so quite a lot of stuff already to go through. Okay, so let's so that's about as much slides as you're gonna get today. So let's save them for later and start talking about the problem. So music recommendation with XGBoost is a bit of a surprise to me, right? Because I thought recommendation was a very, very hard problem, and that we could only use very fancy deep learning models. And here we're using XGBoost. So, okay, fair enough. But how did we frame the problem so that it can be actually learned by XGBoost?
So we are framing the problem today as a regression problem. So because we are going to see that in details later, but each track has a number of features such as energy, speechness, tempo, jar, and so on.
Okay.
And we can actually frame the problem as a regression problem instead of using more advanced deep learning techniques.
So we're trying to predict a numerical rating, yes, from 1 to 5. So okay, that's a regression problem. That's a regression problem. But if we look at the data set, we can see so that's the tracks, CSV file. So as you said, length, energy, speechiness, how much speech is in that track, and all these are values between 0 and 1. Okay, 0 means no speech, 1 means it will just be spoken text, basically. Same for how instrumental is the track, how is there a live audience in the track, the tempo, and the genre. And of course, I'm going to complain,
Yeah, I know.
Because we're 5 minutes into the episode, so it's time for me to complain. There is no heavy metal or hard rock or anything remotely similar. But I guess, I don't need machine learning to tell me what I like. So there you go.
Heavy metal and nothing else, right?
Heavy metal, nothing else. So let's not discuss my musical taste, but okay, these are the tracks and these are the ratings. Okay, so obviously we have a user ID and a track ID that matches the track ID in the other file. The session ID, the location of that song in that session, and then of course the rating. Okay. So fine, but these are all very individual reviews. So assuming I was in this data set and assuming I had rated, let's say, 200 tracks, how would you know what I like?
I might aggregate this feature. And for instance, and after build my recommendation system on top of that.
Okay, so you would look at, let's say, for a given user ID.
Yeah.
You would look at all the ratings for user 11058, right? And look at all the tracks that they like best. So I guess the 5-star.
Exactly, the 5-star.
Find all the 5-star ratings for this user. And then go back here.
And to understand better.
Okay, and say that person likes very energetic tracks and very up-tempo tracks. Compute some aggregated stats on the 5. Yeah, I guess the 5-star reviews are a good indicator. So we'll need to do that, right? Because it's not in the initial data set. So that it's somewhere in our data prep workflow. Okay, I think that's easier to explain. And then these become new features.
Exactly.
Yeah. Okay, these become new features that we can inject. So how many tracks? How big is this data set, by the way?
I think it's quite a big one because the data set is based on the last FM million song dataset with additional processing. And the dataset we are going to work on today is based on 140,000 more or less different songs and tracks for 258 users, if I remember well.
Okay.
So quite.
Okay, pretty. And how many ratings do we have?
If I remember right, 700,000 or something.
Okay. Oh yeah. So reasonably large.
Yeah.
Okay. And probably lots of ratings for each individual user. So we should be able to do an okay job. Okay. So this is the data again. Just quickly, the tracks with the properties and the track ID that is referenced in the ratings, and the ratings have the user ID and the rating itself. Right. Okay. Fair enough. So should we look at data prep now?
I think so.
Okay, because there's probably a bit to do here, and that most importantly, we need to compute those user preferences. Okay. All right. So let's start looking at this, and here we're using SageMaker Data Wrangler. Okay, so SageMaker Data Wrangler is the data prep capability in SageMaker. and you can visually, so you can import your data sets, which we've already done. And then, of course, you can create, you can add transforms. So we have some existing transforms. We can take a quick look. Okay, so you see a sample of your data set here. And then you have a long list. You have hundreds of different transforms that you can apply, right? And so here we've applied just a few things, very simple ones. And for tracks, so we actually insert a new column, which is called event time with a timestamp. And we can see this here. Yeah, it's in there. I think it's the custom formula. No, it's the custom price. Yes. Okay. All right. So here you can see we add a new column with a timestamp, and we'll need this for feature store. We'll talk about that later. And we can see there's a custom formula that computes a new column as well called danceability, which I don't like. So I should rename this one headbang ability.
No.
And I would use a different formula, but again.
Don't be grumpy.
Yeah, I can be grumpy. Come on, I'm supposed to be grumpy. But anyway, we do a few things. We one-out encode categorical features. So here we want to encode the genre, etc. Okay. So for the tracks, that's about it. And for what do we do for ratings? Let's take a look at that. It looks like we're not doing a lot. Probably also inserting that timestamp, I would think. Okay. Again, this is for feature store. We'll see why. And then data types, just typing the columns. Okay, so not a lot of work.
I thought you can export as well, right?
Yes, and we're going to actually show you that.
Okay.
So for the two tables, so to speak, here we do actually very limited work, but then we join them. Okay, so it's something you can absolutely do in Data Wrangler, and so we join them on the track ID, I would think. Yeah. So that now for each review, we also have the track features, same row, because we need to compute those aggregations, right? And this is what we do here. So we actually apply this PySpark transform, right? And it's a little hard to see here. But let me maybe I can just copy paste, show you this in a notebook. And basically what we do here is, we just, so we take all those numerical columns, as well as the one-hot encoded genres, and we compute averages. You could probably think of more fancy techniques, but okay, for this use case, average is fine. So we just take all the 5-star reviews and we average all those values, and then that becomes the user preferences. Okay, so that's the one of the output for the workflow we have here. Okay, and so here again, in the interest of time, because it's not so interesting to watch me click. We've done this, but if you want to go and add more transforms, you can just go and do that. Okay, so just go back to whatever data source you want to tweak, and you can go and add more. Okay. So now that we have this, how do we run it? Okay. What are our options? How do we actually apply those transforms? Okay.
You need to go to export.
We need to go to export. Absolutely. So. We could say, so let's say, okay, we want to export all steps. So we can select the steps that we want to actually apply. Click here. And then we get plenty of options. So we can save to S3, which really means run a SageMaker processing job. So SageMaker processing is one of my favorite capabilities. It's so easy to work with. And it lets you run all sorts of batch jobs, right? So this could be data prep, they could be model evaluation, they could be literally anything. All the batch stuff you need to do in ML is really, works very well with the SageMaker processing. So here we run a job on managed infrastructure, just one line of code to do this, or a couple of lines of code, and you get your process data in S3 or storage service. Okay, so that's one way. Another way is Python code. So you just want the code that runs that feature engineering workflow because you want to put it in your repository and you know you don't want to necessarily run it on AWS. You just want the transform code. So you can do that fine. Then you can actually create a notebook that exports that data to feature store, and this is what we're going to do here. And we'll see why this is interesting. And then pipeline. Okay, which is for automation, and we'll cover that in a different episode. Okay, so let's take a look at So this is the flow file, the workflow file in JSON format, and we'll come to that in a second. But now let's move on to how do we run this thing. Okay, so here we're going to do it 3 times basically because we want to process tracks. Okay, we want to process ratings, and we want to build the joined user preferences. Okay. So we actually have 3 notebooks. So we're going to go, and they do exactly the same thing for different sources, but we're going to look, let's say, at tracks. Okay, and the workflow is always the same. So again, what we're trying to do here is we have this workflow that we built, and we want to programmatically run it over the data source itself, and grab the transform data and ingest it into SageMaker Feature Store. Okay. Perfect. Okay. So 3 notebooks to do this, but let's look at tracks. Okay. So first of all, we have some dependencies. So we need to have a schema for that the feature store, which is really just the name of the features and the types. Okay, super simple. So that really matches what we've built. Okay, and these are called feature definitions. Okay, and next we're going to create our feature group. So a feature group is basically it's an object that stores features coming from a data source. Okay. So here it's a CSV file, but it could be a database table. Okay. So it's good practice to have one feature group for each data source, right? Makes it simple to manage. Okay, so there's a bit of a setup code here, but basically here we create the feature group. Okay, we give it a name, pass the schema. Okay, and then we just create it. Okay, fine, super nice, super simple. 2 very important columns, the record ID and the event time. So record ID is the unique identifier for each row. So here, obviously, we're going to use the track ID, and we'll use the review ID for the other things, etc. So it's the primary key, right? If you want a SQL analogy, it's the primary key for that data source. Okay, so if you have that in the data set, fine. If you don't have one, you need to create one. Here we can just use what we had, and the event time, which is a timestamp. So the times. Yeah. This is the reason why we created it. Yes, and we created it because and we already have a timestamp for the review itself or the rating, but here it's the timestamp for the feature, the engineered feature. When did we create those new features? Okay. Because over time we could have different versions of the of our feature engineering scripts. So we can manage thanks to these timestamps. Okay. Yeah, so we could say, okay, we have this new feature engineering process, and fine, we apply it, and we push those new features to the feature store, but they have a more recent timestamp, so we can navigate the different versions of the features over time, right, which is pretty cool. Okay, so we create it, we wait for it to get totally created, and now we can actually run our workflow and push data. Okay. So again, we're doing this with SageMaker Processing. So it's very simple. It's a batch job. It has inputs and outputs. Okay, pretty cool. So inputs, unsurprisingly, are the tracks.
CSV.
Okay, the CSV file, the location of the CSV file in S3,
And the output.
and the location of ratings in S3.
Okay.
Okay, so the batch job using a built-in container will read those files and apply the workflow that we created. Okay, so how do we do that? That's the output.
Okay.
So the output is, actually, if you look back at the workflow, like I said, we have three outputs. We have one output here for tracks, process tracks. We have one output here for process ratings. And we have one output here for user preferences. Okay, so here in this case, we are looking at tracks, I believe. So we want to catch this.
The notes. Okay.
Okay, so you're literally saying to SageMaker Processing, run this workflow and run this workflow until here, and save me that output to S3. Okay, so how do you do that? You give it's here. You give the identifier of the node.
Okay.
Okay, in that graph, and that's what you find in that JSON file. Okay, so if I look for, let's look for this, should be enough, should be unique enough. Okay,
Okay.
I can see, right, this is, okay, this is the input, okay, this is the actual node, right? So this is the actual node that produces the data that. Okay, so that's how you can actually pick, and this is a very cool feature, I think. You can actually, you can have a one workflow like this, and you can pick process data literally after each step, right?
Okay.
So that's why here we have one workflow, and which we run 3 times, but we just grab the output at different stages. Okay, and then of course we decide to push that stuff automatically to Feature Store.
Okay.
And we pass the feature group name. Okay?
Perfect.
So that's pretty much all there is to it. So we actually upload the flow file to S3 because that's where SageMaker Processing will read it. And then we just run our processing job. Okay? So we pick the instance size and instance count that we want to run this job on, and there we go. And then we just fire it up. Okay, and it runs, and it saves the data. Okay, and we do this 3 times, right? We do this for user preferences, we do this for ratings. Okay, so now that we've processed our data, okay, now that it's fully ready, we can go and train our model. Okay, and the purpose here is obviously to train the model itself, but also we're going to use SageMaker Debugger to compute and store feature importance information and explainability information with SHAP. Okay. All right. So let's see how this works. So we have some setup code, and the first step, of course, is to build the dataset, because what we've just done is we've created 3 feature groups. Okay. One for ratings, one for tracks, one with the user preferences, the aggregated stats. Okay, so we want to train from that. So that data right now is stored in what we call offline feature store. So it's basically S3. Okay, and we can go and query the data directly in S3 with Amazon Athena. Which is one of our data services, and the really cool thing is we can query in place. Okay, so we don't have to create a database. The data is in S3. We can query directly. So we're going to do that. Okay, we're going to do that, and the reason why we can do that is because when we create feature groups, by default, we automatically create an Athena table. Okay, maybe I can show you that.
Under the hood. So.
Yes, you can disable it if you'd like, but you know why? Okay, let's take a look at Athena. Okay, so we can see we have a database called SageMaker Feature Store, and we can see here, yes, SageMaker Feature Store, and we can see we have tables, right? And okay, we have some different things here, but we see actually the three tables.
For rating.
Okay, so we have ratings. We can easily preview them. Let's go and do that.
Cool.
Okay, so again, what's running here is it's a SQL query on the feature group data that's stored in S3. Okay, and I didn't create anything else. It's you know, I didn't set up anything that you didn't see. Okay, we created the feature group, and that automatically created a table, and Athena knows how to map that schema to the data in S3. Okay, so we have ratings. We have.
So this is the reason why we need to define the schema as well before.
Yeah.
Okay.
Yeah, that helps.
That sounds.
And okay, now we see the tracks, right?
Mm-hmm.
The process tracks. Okay, and this is the new thing we created during pre-processing. We see the 5-star aggregated preferences. Okay, so for example, we see that user 11063 likes reasonably high energy songs and a very, you know, doesn't really like acoustic songs. You know, they really don't like either instrumental songs, etc., etc. And we can see the genre, and the favorite genre is rap. Oh my god. It is actually rap. Okay, see, but it's the demo effect. Okay, but then again, you know, it's fine. You can listen to what you like. And so these are really, you know, these are really important because this is what we're going to train on, because now, you know, for each track, for each rating. Okay, if we take a rating and if we join those features to the rating, then we can see, okay, so this track with these properties was rated 215 by a user with those preferences. Okay, so now you have all those features on the same row. So you can see, okay, if that person loves rap, then okay, it probably makes sense if they, you know, if they give low ratings to, I don't know, classical or dance. Okay.
Okay.
And so that's the story here.
And this is the reason why we talk about the regression problem.
Yes, because now we have all those features and we try to predict the rating itself. Okay. So these are all the features we're going to put together. Okay. So that's what we need to do now. And you know, building the data set. Okay, and so this is where we're going to so we're selecting 500,000 tracks. Okay, so it's a limit that we set, and we're actually merging those ratings with the two other tables. Okay, so you could say, well, why didn't you run? You could actually run one big SQL query that does the join. Okay, here you know, we have simple queries and we use pandas to merge. But if you want, you know, if you're more familiar with panda's fine. But you could also run you could run that monster SQL query that actually queries the three tables and joins. You know, you can do the same thing. Okay, so that's really what we're doing here. Okay, so we query the three individual tables, and then we merge. Okay, but again, we could have one single query and join everything. Okay, and so that gives us the data set that we just talked about. So we have all the ratings, and then we have so in the ratings we have the track ID and the review ID, and the user ID. Okay, so in each review we have the track ID and the user ID, and so we join on those two things. So now on each row we have the rating, the review information, the user preferences, and the track information. So quite a few columns in there. Actually, we have 37 plus the label, the rating itself. Okay, and that's the data set. Okay,
That's cool.
makes sense. All right, so yeah, we split it for training and validation, and then we save it, okay, to two CSV files, which we upload to S3, because again, that's where SageMaker wants the data to be stored. Okay, we configure our training inputs, okay, which we're going to pass to the training job, okay. And now, okay, we need to configure the actual training. Okay. So a few things here, infrastructure requirements. Okay, and SageMaker is fully managed, so we don't worry too much about that. We just say, hey, go and train on 2 M5 4XL instances. That should be, you know, fine. And if that's too slow, we can add more, and you know, it should scale.
Built-in.
Yeah, the built-in algo, so the container, all training activity is and deployment activity, for that matter, is based on containers. So here we use XGBoost, which is built in SageMaker. Okay, and we select the version that we want. We prepare some hyperparameters for XGBoost. Okay, so regression problem, we use a squared error as our metric, and we can set all the hyperparameters that XGBoost supports. Okay, and we put everything together using this very important object in the SageMaker SDK called the estimator. Okay, so we pass our infrastructure requirements, the location of the container for XGBoost, the hyperparameters, and yeah, where to save the model. Okay, so that's typically what you pass. Here we added a little bit more. And we added SageMaker Debugger information, and SageMaker Debugger will save a model state during training. Okay, and you can specify the save interval, number of steps that you if you want to save every 5 steps, 10 steps, etc. And here we can save a different number of collections. So here we decided to save metrics because we want to plot them, feature importance information. The local or the full SHAP values for each sample in the training set. So we'll have detailed SHAP values and global SHAP values for the data set. So if you're familiar with SHAP, you know exactly what we're going to see. If you're not familiar with SHAP, SHAP is basically it's a super cool library and technique that helps us understand how features contribute to the output prediction.
Exactly.
And how each value, individual value predicts. Okay, so if you have a high feature value, does it influence the prediction, up or down? And if you have low value, does it influence it up or down? And you can build all those cool plots that you can see in a minute. Okay. So SageMaker Debugger also lets you configure rules that will check for unwanted conditions and in your job, and they will actually stop the job and then send an alert if the job doesn't behave the way you want. So here, just for the sake of it, we say, hey, if loss is not decreasing, then stop the job, because we might be overfitting, we might be spending our time and money inefficiently, so no reason to continue. Okay. All right, and then we just train. Okay, and this is really a one-liner here. So we call fit, passing the location of the training set, the location of the validation. Okay, and this lets you reuse a previous model or train a new one. But really, it's really a one-line operation here. Okay, so it goes and trains. So it fires up the amount of infrastructure that you decided to use. It pulls the container, it loads the data, and fires up the training job. Okay, and we can see the training rounds. And once the job is complete, the infrastructure is automatically shut down. This ran for about 20 minutes, and the model is saved in S3. Okay, and from there we could go and deploy, etc. But we'll do this in September in another episode, where we focus more on ops and automation. Okay. All right, so now we have a trained model and we have all the information that SageMaker Debugger saved automatically in S3. So now we can go and load that data from the output path in S3. Okay, and for example, we can load. So we have utility functions to load the collection of tensors that we saved and plot them. Okay, these are reasonably generic. So for example, we can plot the metrics. Okay, so here our metrics was mean square error. So we have the training value, we have validation value, and we see the job went pretty well, right? Mm-hmm. It's we didn't train for too long, and so looks like the model learned something. Okay,
that's a good news.
It's good news. Yeah. It's good news. And of course, you see those metrics in the training log, and you see them in CloudWatch or monitoring service. But I think it's good to also, good, yeah, you don't have to jump
and you've got
to different consoles. Yeah. You can see everything. Okay, and we can plot feature importance. Okay, so pretty useful. And we can plot sharp values. Okay, over time. Okay, so we see, we can see there are 3 features here that are a little more important than the other ones. So, you can go and investigate and, and decide if, it's not feature important, sorry, it's sharp value. So you can see, these have a positive outcome, a positive impact on the outcome, and these tend to have a negative impact. And so we can see again, global values, etc. Non, je dis une connerie. Ça c'est average sharp. Okay, and we can see local individual values. Okay, so here we see sharp values for each row in the each instance in the training set. Okay,
it's super important for the explainability of your ML model.
Yes, and so the blue and red scale is about the feature value. Okay, so you can see. So let's try and see. For example, this one here. This one here is very clear as well. So here we see that, so we see strong red on one side, strong blue on the other side, which tells us that there's a clear difference between low values of the feature and high values of the feature. So here, if we see that basically people who love rap, right? So people who have a lot of rap songs in their 5-star reviews, okay, will actually strongly impact and consistently impact the predicted output. Okay, so that means if you don't like rap, it tends to, if you have very few 5-star reviews for rap songs, then it has a very clear impact. So I might be wrong, but what this tells me is either you love rap and you probably don't like anything else, right? Because again, this has such a strong impact. So if you love rap, then this is really what your thing, right? And if you don't like rap, then again, you will tend to really score rap very, very low. So it's a very polarized view, right? That's what I'm trying to say. Which we might see, which we don't really see
with Latin.
For example, Latin is a little bit more balanced, right? So you could like Latin music and some other stuff, but yeah, just to be fair to rap fans, I guess if you had a metal thing, it'd be even more polarized. So that's fine. That's
I'm a huge fan of rap. I think heavy metal and rap.
I didn't hear that. I'll remove this. I will edit this bit. We didn't hear this. Okay. So anyway, you can look into SHAPs into SHAP great detail. It's a really
Important.
yeah. It's a really important mechanism in understanding what the impact is, and yeah, this one here is very interesting as well. Blue in the center and red on the extremes, instrumentalness. So yeah, some people probably love instrumental music and or totally dislike instrumental music. I don't know. It's worth analyzing those and trying to figure out what people what that tells you about music habits. Okay, well I think that's what we wanted to show you today. Again, there's more stuff, but we'll keep that for a future episode. Okay, so we started from CSV files. We processed them with flows, okay, that we built in Data Wrangler, and we saw all the transforms we could apply, and we ran those transforms automatically with SageMaker Processing, and then we uploaded that process data to S3, and we trained a model on that. And we saw how we could explain and see feature importance for that model. Okay, so again, let me show you where that repository lives. Okay, really quickly. It's time for the screenshot. Okay, so you can go and grab that. You can absolutely run it yourself. Go over all the code and tweak it and make it your own. Okay, and this is a really interesting example. And again, we'll come back to the downstream task, model registry, etc., and automation with pipelines and so on.
And I think it's a good example of the data scientist daily job. It says you've got some data, you're gonna create some new feature on your data, and after you're gonna do you want to automate your processing, and after of course you train your model, and you can after understand it better thanks to debugger and this kind of.
Yeah, and here we make it look very linear, but in real life, obviously, you iterate a lot, and you know it's a little more
stochastic.
Yes, I don't know what that means, but yeah, it probably is very stochastic. No, I'm just kidding. But yeah, it's here you see the final project, and but this you can build this iteratively, and the good thing I think is in SageMaker we have hopefully all the building blocks that you need, right? So you can start processing your data manually, and then as you saw, it's really easy to automate. Once you've clicked in Data Wrangler and transform the data the way you like, it's one click away from running that automatically again and again and again. Okay, and again, once you have your final features, you push them to Feature Store, and you're one SQL query away from okay, here's my data set, and you don't have to run all that processing again. You've done that. Okay, you've fully processed that reasonably large data set, and you can just select subsets that you want for a particular task. Okay, and then training and training is actually the easy bit. It's just a few lines of code, creating the estimator and calling fit.
SageMaker.
Yeah, SageMaker business as usual. Thank you. I had managed not to say it, but there we go. Okay. So again, this is the notebook. Go and grab it, run it, and get in touch if you have questions or feedback. We're always interested in that. And I think we're getting close to the end of this episode. So did I forget anything?
No.
No. What are we gonna cover next time?
Next time it's
next time it's I think it's a fraud detection. My favorite scenario. Yeah, fraud detection is really important as well for everybody. Sure. Yeah, so we have a nice fraud detection example, and I think this one includes bias analysis and bias mitigation. So we'll talk about those really cool techniques, and we'll talk about data prep again, and we'll revisit some of those topics and add more. Okay?
Perfect.
So I think that's it for today. Sego, thank you so much.
Thank you.
Always a pleasure. And thank you everybody for listening. I hope you learned a few things, and see you next week for another episode. Thank you and bye-bye.
Bye bye.